So number one, hoping that you follow the order of operations. If you follow the order of operations, you do the multiplication first. And maybe, just maybe, did y'all notice that the 2's would cancel on the multiplication? You could do that. So you could say the 2 cancels with the 2, giving us negative 3/4 plus 3/5. If you didn't cancel the 2's, it's okay. It'd still work out just fine. And it's frozen. So there's that. And then to add, you need a common denominator. The common denominator would be 20. And so if I do get that common denominator, I would get negative 15/20 plus 12/20. When I add my fractions, I add the numerators, leave the denominators alone. I end up with negative 3/20.
Yeah.
Any questions on number one? Okay, then number two, we've got some distributive properties to take care of. So the 6 gets distributed, giving me 18x squared minus 42x plus 24. Minus 4x squared minus 9 is that minus sign. Also gets distributed to both terms inside the binomial. We'll talk about that terminology later. And then we add our like terms. So 18x squared is like negative 4x squared. This gives me 14x squared. The negative 42x does not have anything like it, so it just gets copied down into my answer. And then, of course, 24 and negative 9 are like terms. They would add up to be 15. So plus 15 would cap off my final expression. Again, questions on number two? Looks like you're all getting these right. It's awesome. Okay, then let's take a look at number 3. So number 3 says John went for a hike. The temperature at the trailhead was 55 degrees Fahrenheit. At the summit of the mountain, the temperature was 42 degrees Fahrenheit. I'm really hoping that at some point in your lives you already have or you soon will experience this, right? If you climb a mountain, typically colder at the top than at the bottom. Just how it works. Trailhead elevation was 8,500 feet. The elevation of the summit was 13,800 feet. Write an equation in slope-intercept form that shows the relationship between temperature and elevation. So in writing that the way that I did, I was trying to give you a little bit of direction, basically saying that temperature depends on elevation. So temperature would be the dependent variable, elevation would be the independent variable, meaning that temperature is kind of like your y, elevation is kind of like your x. Okay? Temperature is like y, elevation is like x. So if I'm going to write the equation of this line describing this, then I need to have a slope and a point. Any suggestions on what I might do to get the slope? Like what numbers would I use? Joe, go ahead.
42 minus 55 over 13,800 minus 8,500.
Okay. So he's got basically the change in temperature divided by the change in elevation. Does it make sense to you guys as well? Obviously, it makes sense to Joe. What do the rest of you think? Anybody have it like flipped around vertically, like you have the elevations in the numerator with the temperatures in the denominator? So here, if you did that, you just want to keep in mind what depends on what. Since temperature depends on elevation, temperature would go in the top, elevation would go in the bottom. Okay. So then, as you do a little bit of simplifying here, you end up with negative 13 over 5,300. And that's my slope. Negative 13 over 5,300. And I also, of course, need a point that is on the line. I've got a couple of choices here. What did you use? Any suggestions? Wait, go ahead. Okay. And, of course, you could have picked either one of the data points there. Whit chose that one. It'll work out just fine. Okay, so then if I am going to eventually get to slope-intercept form, I've got to start off with point-slope form because that's what I have. I have a point and a slope. And so I will write this as t minus 42 equals the slope times e minus 13,800. Using t's and e's again. If you used y's and x's, that's fine. You just have a y in place of t and an x in place of e. I'm okay either way with that. All right, and then I'm not sure how the numbers work out here. I need to get the t by itself and do some simplifying. I do know that it's going to be t equals negative 13 over 5,300 e, and then it's going to be plus something, right? Anybody get the plus something? 75.5? 75.85. Anybody confirm that? I think I will, just to be for sure. Could be right. Definitely agree with you. Okay, so that would be your linear equation right there. So again, any questions? There's a lot of things you might ask here, like why did the temperatures go on the top and the elevations in the denominator? Why did you use T's and E's? I don't know. Maybe you understand all those things, but a lot of questions you might ask. Anybody? Go ahead, Noah.
Is it okay if you use X's and Y's if you clarify what they mean?
Sure. Yeah, so if you have this, that's great.
That's
Yeah.
what I have.
Y stands for temperature, X stands for elevation. Not a problem. Others, thoughts? Yeah, Joe.
So it'll never matter which point you decide to use it, because I used 55 and
8,500.
8,500.
And you got the same answer we did, right?
Yeah.
Yeah, it shouldn't matter at all, because if those 2 points really are on the line, whichever point you choose, you should still get the same y-intercept. Yeah, and that's a good way to check yourself too, actually. Like if you had the time, like find the linear equation with 1 point and then try the other one. And like you said, they better be the same. Yeah. All right, anybody else? Okay, so I know a couple of folks took a shot at number 4. And so maybe what we'll do here, why don't I show you number 4? And this will be a nice segue into more practicing with this D equals RT kind of stuff. So here we go. Number 4 says, Abby leaves her house in Highlands Ranch for the mountains on Friday at 5 p.m. She drives an average of 40 miles per hour. Her sister Candace leaves the house at 7 p.m. and she drives an average of 60 miles per hour. Mountain House is 110 miles away. Will Candace catch up to her sister? Show your work. If she does, at what time does she catch up to her? So as I kind of recommended yesterday, I really think that it's a good idea to draw a picture of this before you do any kind of math. Just like read it like a story. Don't get too hung up on the numbers and think, wow, where does the 110 go and all that stuff. Don't do that at the start. Just draw a picture. Here would be my suggestion for a picture for this one. Is Abby the one that gets the head start?
Yeah.
She does, yep. So I'm going to say that this is their home right there, and Abby gets the head start. So she heads on out that direction. Candace starts here, and she goes in the same direction, and she's going to try to catch up to her sister. And so we're going to say that that right there is the catch-up point. We're going to decide whether that point really happens or not before they make it to the house. Does that make sense? Okay. So I'm going to label this up here with distance of Abby. I'll just put D sub A, and I'll call this distance down here D sub C for distance of Candace. And then the last thing I want to figure out here is how many miles of a head start did Abby get?
80.
80. How'd you get that?
Because she left 2 hours earlier, and so you do 40 times 2.
That's right. D equals RT, right? Yeah. So 40 miles per hour for 2 hours, it's going to be 80 miles. So she got a really big head start. So 80 miles is right there. So then what we need to do is we need to think of a true relationship involving the distances, right? And this is the thing we put a lot of effort into yesterday, and it wasn't easy. We're going to try to write an equation that involves all the stuff in the picture, and it's got to be true, right? So there's a number of things you could say. Any suggestions? What do you think, Noel?
Does 80 plus GA equal GC?
Okay, so let's let everybody judge this. So she wrote something that involved all the things in the picture, right? The big question is it true? Is that really true that 80 miles plus the distance of Abby would equal the distance of Candace? based on the picture. It's true. Isn't that 100% true? Absolutely, right? The head start plus the short distance should equal the bigger distance. We're simply writing down something that's true, and that's true. Okay, so then we need to recognize, of course, that D is equal to rate times time. So I'm going to fill in a little more detail here. What is Abby's rate? That's right. And her time is an unknown, so we're typically just going to use the letter T for time. We don't know what that time is yet. We'll just put a T. Equals distance of Candace. So what is Candace's rate?
60 miles per hour.
And her time?
T.
Again, it's the same unknown time that we don't know that we're trying to find out. So then once we've done this, of course, we've created a relatively simple equation for us to solve. And so we would subtract the 40T over, and that would give me 80 is equal to 20T, dividing both sides by 20. I got 4 equals T. So now we can actually answer their question. So the question was, will Candace catch up to her sister? Any thoughts on yes or no and why? What do you think?
Yes, she will catch up.
Yes, she will catch up to her?
They're at 4 hours.
In 4 hours, right? But remember, the mountain house is 110 miles away. And so if Abby beats Candace to the mountain house, Candace won't really catch her, right? Abby will stop at the mountain house, and then later on, Candace would show up, right? So that's not really catching her. What do you think?
I do another equation.
Okay, what do you think? Yeah, go ahead.
So dA plus DC equals 110.
dA plus DC equals... So you're proposing this as an alternative to that? Okay, what do you guys think? Is that true? Is distance of Abby plus distance of Candace equal to 110 miles?
No,
Why not?
because that's how far the mountain house is.
That's how far the mountain house is. And
So they both have to drive
don't they both have to ultimately drive 110?
Yeah.
So I don't think that that's true. I think we could maybe adapt it a little bit.
Like mixed stuff. That was where I started.
Okay.
Adding in-
Yeah. So they're driving 2 separate cars, and Abby, she's going to have that 80-mile head start. But then when you think about what else she drove, she's going to drive the full 110, right? And so is Candace going to drive the full 110. So I could change this a little bit, couldn't I? I could say distance of Abby plus distance of Candace is equal to 220. That would be true, wouldn't it? We could actually use that if we wanted to. I think it would take a little bit of different navigating to get there, no pun intended, but it could work. Noah, what do you think?
Could we do distance equals r times t to check our answer? So, because we know
Yeah.
the time and their rate now.
We still haven't really answered the question yet, right?
Well, yeah, but if we use because that's the time that they'll catch up. So we could use 4 because that's like how many hours. That
Okay, so let's use that. So
and see if that
for Candace to catch up to Abby, it's going to take her 4 hours, right? What is Candace's rate?
rate is 60 miles.
And the time that it would take her to catch up is 40 equals...
240.
So it's going to take Candace 240 miles to catch up to Abby.
So they wouldn't.
So she can actually catch up to her.
No, they'll just. be
No. They'll just meet at the house, right? But there's no way that Candace can catch up to her because it's going to take her 240 miles, and the mountain house is only 110 miles away. Does that make sense? So that's kind of the way you would conclude this one to answer the question, will she catch up to her sister? In this case, the answer is no, she will not. She's going to run out of road, right? She'll catch up to her when she gets to the house, but that's not really catching her. If that makes sense. Okay. Again, not expecting you to have this mastered. Let's keep working at it. Jaden, your question? Okay, that is possible. The one thing we want to be really careful of, and I have no idea what way you did this, we want to make sure that we're using algebra. If our method is like, if our method looks like this, stuff like that. And I have no idea if you do that or not. I've known some folks that have done this. This is not really algebra. This is just sort of like adding some numbers up and being like, all right, let me just compare these things. It's not really defendable. It's not really repeatable either. It just kind of works for this set of data, and it may or may not even work. So I'd love to hear what you did, Jaden. Jaden's method was what?
I did how long it would take for Abby to get there and how long it would take Candace to get there.
Okay, so let's see here. So when you say how long, you mean time, right?
Yeah.
Okay, so time for Candace and Abby to get there. So what'd you do? Like what'd you write down?
Two separate equations.
Sure.
Abby,
So
I did 110 equals 40 times t.
hang on one second. So for Abby, you said 110 equals 40 times t. And for Candace, you said,
110 equals 60 times t.
okay, does that make sense to you guys? Okay, keep going.
And then I divided 40 on both sides for Abby.
Sure. What'd you get when you did that?
I got 2.75.
Okay.
And that'd be hours.
Yep, 2.75 hours.
And then for Candace, I did 60 divided on both sides. And I
Yep.
got 1.83 hours.
Okay.
And then since Abby left 2 hours above Candace, I took 2 hours away from her time to get there, and it was 0.75, and it would take Candace 1.3 hours to get there, so Abby would still get there before and less time.
I like it. The only, I think this is a really good method for this specific question, and I have no problem with it at all. I think it works really well. Where you're potentially going to run into issues is in the scenario where Candace really does catch Abby. It's going to be harder to answer those questions using that method than the other way, but I think for this way, that's very logical. I like it. Whit.
I did the same way he did, except for instead of subtracting 2, I added 5 to Abby's time and 7 to Candace's, because that's when they left.
But we want to be really careful with that, though, because 5 p.m. and 7 p.m. are times of day. They don't really have anything to do with the time that it took you to travel to wherever you were going. That makes sense? So if you added 5 hours to Abby's time, that would tell you like the time of day that she actually got to the mountain house. And then with Candace, it would tell you the time of day that she got to the mountain house, which could then still kind of be used, but you want to be careful when you mix those that you understand what the result means. That make sense? Okay. But again, I would say the same thing. I think that's logical, and I think you're using really good thinking, and I got no problem with it at all. I think you're going to run into a lot of problems if you try to use that method in a scenario where Abby really does catch up to Candace on the road. And looking at this at the start, it's kind of hard to tell right away, right? Like it didn't just immediately be like, oh yeah, clearly she's going to catch her, or clearly not. So I would advocate for the method that will work every time. Something to think about, but your choice for sure. It's pretty good progress. Again, I'm not expecting you to have like these questions just super mastered right now. We're in progress, right? And so I'm hoping that over the next couple of weeks, we'll all get to a place where we feel really, really comfortable with these. So today, let's do some more. If you guys would flip over to our number 1 here on our practice, and a little bit different. So just like we did yesterday, we're going to be super duper consistent with this. I'm going to just ask you to read this as a story. Please don't get hung up on the math. Don't freak out about numbers yet. We'll do that later. Simply read this thing and try to draw a picture that represents, like a picture of the distances that represents what's really going on here. And then if you want, if you get to this spot, see if you can write an equation involving all that stuff that is true. Okay? So I'll give you a couple minutes to try that on your own. Feel free to compare. I'll be around to help if you need it. It says these 2 remotely controlled unmanned aircraft are launched in opposite directions. Looks like they started about the same spot. And so I'm going to say that this is their starting spot. One of them goes east, and the other one goes west, opposite directions. I'm going to try to be careful about this. I'm going to say something like this. So there's always going to be a temptation to say that, hey, this will be really, really easy, 560 miles per hour. Let's just go 560 divided by 2. Why is 560 divided by 2 not a viable option?
Because they're not going the same miles.
Yeah, they're going different speeds, right? One of them's going 82, the other one's going 78. So they're going to go almost the same distance, but it's not going to be exactly the same, so we cannot assume that. So there's my picture from a really basic perspective. Does that picture make sense? All right, so I am going to label these. I'm going to call this the distance of the aircraft that went east. So distance of the eastern one, and this will be distance of the western one. Could be D1 and D2. I don't know. Whatever. There's one last thing that we need to put in this picture, and that's the 560 miles, right? That's a distance. How should the 560 relate to those? Okay, great. That's awesome. So it would be this full distance between them at the end. And so Kyrie just suggested dW plus dE is equal to 560 for a relationship. What do you think? Yep. Okay. So then if you guys would, see if you can bring it home now. Right? So this is a good picture of what's going on. We got a good equation that's true that relates all this stuff. See if you can bring it home and answer the question, how long will it take? It's a time. How much time will it take for the aircraft to be 560 miles apart? So number 2, if you read this as just a story, you see that the rescue teams leave base at the same time. One of them heads north, and the other one heads south. Something like that. I'm going to say that this is the distance of the team that went north. This is the distance of the team that went south. Question says, how long will it take them to search a distance of 21 miles between them? That tells me that at the end, there should be 21 miles from one group to the other. So from writing a relationship perspective, I would say distance of the team that went north plus the other team's distance equals 21. Does that make sense? Okay, now remember the distance is the same thing as rate times time. And so I'm going to replace the distances with rates times time. Distance of the team that went north, well, the rate was 2, wasn't it? So I'm going to say that this is 2 times an unknown time. That's what we're trying to find out. Plus, the other team had a rate of 4, so 4 times t. Distance again equals rate times time. This equals 21. I end up with 6 times t equals 21. Dividing both sides by 6. And I think you were right. I think it does end up being 3.5 again, doesn't it?
Oh, wow.
Coincidence that these two have the same answers. It is what it is. 3.5 hours. Hold on. I got to hand some stuff back to you. And